Please join me in welcoming Marilyn Waite.
So, raise your hand if you've ever heard of DDT. That's just about everyone, and good to hear. So starting in the 1940s, the synthetic chemical DDT was used to fight malaria and lice. In World War II and the Korean War, DDT was sprayed freely to clear the path of insects and prevent lice outbreaks among the troops. The propaganda for DDT was vivid, ranging from rhymes like, "DDT is good for me," to pictures of children with diseases caused by lice. When scientists began to question the environmental impact of synthetic chemicals, the response was swift. Look, I can eat DDT and I haven't dropped dead. We were asking, is DDT immediately harmful to the human body? But it turns out that was the wrong question. Rachel Carson, on the other hand, asked the right questions. What are the cumulative effects of DDT on ecosystems over the course of many generations? The answer changed the fate of DDT and helped protect human and ecosystem health. DDT contaminated the food chain, caused cancer and genetic damage, and provoked the death of entire species. Carson's right questions led to the right answers and led to a national ban on DDT. Likewise, when it comes to solving our most pressing energy challenges, we too often ask the wrong questions. Between the early 2000s and today, we have witnessed a boom and bust in venture capital allocated to clean energy. And looking back over the past decade, it can seem like it was more of a bust. 90% of clean energy startups funded since 2007 have failed to return even the initial capital. But is it simply the case that startups in the energy sector are bad investments? Should we, as an investment and innovation community, just dial back our investments in energy? Or are we once again asking the wrong questions? Conventional electricity and heat generation go something like this in 4 steps. Step 1, extract a natural resource like gas or biomass. Step 2, harness that resource to create energy, for example, through a gas turbine. Step 3, transmit and distribute that energy over very long distances using a grid. And finally, use that energy for our daily lives, like our microwaves and our electric cars. Usually, when we think about energy innovation, we think about improving something within that process, building a better light bulb, or a more efficient HVAC system. But this has gridlocked us. What if we shifted this paradigm? What if instead of asking, how do we make the energy supply chain work better, we took a step back and asked, what are solutions to ensure the ultimate end use of energy? Which is to do things like move from point A to point B, see at night, eat warm food, going back to basics. So instead of asking about more efficient light bulbs, let's ask about how we can guarantee good sight. Instead of asking about HVAC systems, let's ask about how we can live and work at comfortable temperatures. Here are 2 examples of what happens when we start asking the right questions. Question 1, how do we move goods, our clothing, our food, from point A to point B? So this is a picture of a trucking fleet in the northeast of the United States in February 2015. 400 trucks, over half of them unavailable due to a cold snap, rendering the engines unavailable. Even with low gas prices, these fleets are spending about $45,000 per year per truck on fuel alone. Plus, the fleets spend about $4,000 per truck per year on unnecessary idling equipment. That manages driver comfort and vehicle uptime. This has an impact on both the planet and the financial bottom line. IdleSmart, a startup headquartered in Kansas City, has developed a smart thermostat for Class 8 fleets to solve this problem. Their solution monitors a number of metrics, including battery voltage and engine temperature, is physically connected to the ignition, and allows an automatic start and stop of the truck to charge batteries or warm the engine and fuel line. They save fleets $3,000 per year per vehicle and increase vehicle uptime by up to 60%. Each IdleSmart installation yields a reduction of over 12 tons of CO2 and just under 300 grams of particulate matter per year. They have sold over 1,000 units on 4 of the top 10 fleets across the United States. The founders of IdleSmart wanted to get stuff from point A to point B and cared about driver well-being. They didn't ask themselves, how can I manipulate electrons? They asked themselves, what do truckers need? Example 2, how do we get to Mars? The larger an object's mass, the more force it takes to move it, and rockets are kind of massive. One of the keys to further exploring our universe is to build equipment that is strong yet light. Most rockets use pressure vessel designs from the 1800s, which are a major problem because they take 5 pounds of steel to move just 1 pound of gas. Infinite Composites, a startup based in Tulsa, Oklahoma, introduced the world's first linerless composite pressure vessel for gas storage. They've displaced more than 50,000 gallons of gasoline and abated more than 1 million pounds of carbon dioxide. Infinite Composites developed a product that solves an energy challenge, but they didn't get there by asking, how do I create a linerless pressure vessel? They asked about moving an object from point A to point B, point A being Earth, point B being Mars. So earlier, I spoke about the boom and bust in clean energy startups. But every day, I see great startups solving energy challenges, and a lot of them don't even call themselves energy companies. IdleSmart might call itself a trucking startup. ICT, Infinite Composites, might call itself a materials venture. These companies got where they are by asking the right questions. And we need to ask the right questions as well. By reframing our clean energy investment challenges to be focused on end use, we open ourselves to potentially breakthrough startups and profitable investments. Thank you.